Good day, everyone. Today we will be welcome to my first video, and today we will be reviewing my mini networking project of my high school. And this is a very basic. You could do this with your own projects. You could use it as a reference, and we will be going through with it using a documentation system, and we will have a project overview. Well, this is a project, and you will have billing of the materials and device documentations. We have detailed cabling floor plans. We have a rack diagram or the MDF elevations. We have the cable labeling scheme and port maps and network topology, the IP addressing scheme, configuration and implementation, mapping to the OSI model, verification and testing, and of course, some additional bonus work if you want to. So first of all, let's look at the uh, Cisco logical topology. Yeah. Well, first of all, we made this project so we can implement a sort of a um, network structure for my high school, and of course for having administrative infrastructure support so that admins and staff, the server room can have vital data management that can hold and secure all essential records, including student academic histories, enrollment data, human resources files, and other critical institutional information, etc., etc. And of course, we will allow the faculty and the academic preparation, the teachers can use the internet of the topology that we will be creating, that we have created, so that they can have internet access, have their lessons prepared, have the online resources, and showcase digital learning tools. And of course, the students as well will have access to the internet via computer laboratories and library workstations, as well as having the access to Wi-Fi. Now, first, we must look at the physical topology, and as you can see, we have a first, second floor, and with that, and I think we should break down the network structure first. So we have here 5 routers. We have the main router that is connected to the main server. We have 4 helper routers that connects to different areas of the campus. If we go here, I mean, this is one of the things that you will encounter when you are creating a network topology here in Cisco Packet Tracer. You would notice that it is very it would become very laggy the more stuff you put into it. As you can see, this is the MDF elevation, where if you are going to create a routing system or a network infrastructure, you should always make it realistic. What I mean by that is, you should, when you're making a rack diagram like this, all of the very heavy stuff should always be at the bottom, and all of the lighter stuff should be on the top. Usually the power supply is always the heaviest, since of course they carry the power, and then you have the servers, the routers, and the switches. Same goes with this one. Now, in the logical topology, we have the 5 routers that has a PC. They have console PC respectively, so that we can configure them via PC. Never do it in CLI because that is unrealistic. We should always use the consoles to configure each and every router. And how do you do that? Well, you just put a PC, plug it in the console. Let me just show you. If you have a PC, right, click this console wire, go to the RS232, and then you click on the router and just click console, and then go to the desktop, go to the terminal. Don't need to do anything here, just click OK, and then you have the app. You can now access the router. Enable, configure terminal, etc., etc. You can now uh, go to the interfaces and such. So, yeah, I think I'm using a different one here. I think I'm using 6. Yeah. Anyway, anyhow, that's how you configure a router. Well, I think we should just focus on the routers first. Well, in the router, we have here the main router that is connected to the server. Now, if you want that to happen, this is the server, by the way. I think we should just discuss the server first, since you should always start with the server. Okay, that's the general rule of creating a network infrastructure, is you should always start at the server. Now in the server we have a fuck ton, I'm sorry for the language, we have a lot of subnets. We have the admin pool, we have, I think, a server pool, you have the public or the students that can access the Wi-Fi, we have CCTVs, we have CL, which stands for ComLab, and of course ComLab, that is explicitly said. We have a RFID, of a biometric system, we have the faculty, clinic, library, guidance, registrar, and any department that you could think of in a school. You create a VLSM, or a variable length subnet, so that all of them can have a limited hosting that can give networks to each of your users, to give IP addresses, if I say. Now I didn't utilize IPv6 here. I only utilize IPv4. We don't have a TFTP system, but we do have an FTP system. In order to do that, you just create a username here, for example, Valnut users, create a password, and then you can choose what they can do. It's basically a SQL, but Cisco can allow them to write, read, delete, or rename, or list. You just add that, and in order to access the FTP, sorry, in order to access the FTP, you just open a PC, go to the command prompt and type FTP. Sorry, you call FTP and then 192.168.22.66, then trying to connect, and then it's gonna ask for a username. You forgot that user, or was it actually Walnut user? I forgot. Oh, it's Walnut users. Okay, so you have Walnut users, and then you enter the password. Now it's Valnation. Now, as you can see, when you type in the any password in the command prompt, in Cisco, in any terminal, whatever, you would notice that it is not moving, or it's not typing anything. That's because it's a secret, so that when you are configuring something, nobody can see it other than you, because in your mind you know what the actual password is. So okay, now it's logged in. Now if you type dir, then you would see, or maybe ls. If you type dir, I think it is permission denied. Yes, it's permission denied because we are only a Walnut user, and because we are Walnut users, we can only read or write. We cannot see the list, or we cannot show it. So we type quit, quit. Okay. Then we try it again. FTP 192.168, and then we go for admin, then admin, and then we type dir. There we go. You would list all of the files in the files FTP server. So the FTP works. Now let's see if the HTTP works. Now, when you create a server, you should always try to have multiple servers that does does its own does its does it does its own service, because as you can see here, I also have an IoT which stops me from using my HTTP. Now if I turn this off, this would allow me to use it. Okay, so the HTTP, we go to a PC again, then go to the web browser. Now I have created a custom HTML CSS file in that server. I'm just gonna show you there. I've created, yeah, look at that. I've created a custom HTML file here, and if I call upon the server's IP address in this web browser, it should give me that. So 192.168.2.2.66, and if I click go, there we go. It's gonna show. It's gonna be clickable. So the HTTP works. The HTTP service works. Now, if I also implemented the DNS service here, so when I call upon this domain name, it would redirect, it will automatically direct me to the IP address that I have put in my server. So if I call upon, sorry, walnut.com, it would show me the same website. Yeah, there we go. So the DNS just calls upon the server of what the HTTP has. Okay, so we can say that the DNS server works. Now I think that's all to it. I have not created an email system, on anything, an AAA or a syslog. I have not created any of those. This is just a simple project that utilizes DHCP relays that can make and create and connect multiple. It just makes a network campus, and yeah, I'm gonna explain to you how I did it. Now of course you have this multiple routers right here, and we need to connect them statically. As you can see, I have multiple network addresses here. Now when you create a network address, you should always type in the network, meaning the first host of the network, which is usually 0 if you're using a classful network address. It's usually 0. Now if you're classless, it might be different. Might you need to do the math and do the subnetting for it, but it's usually just the network, the subnet mask, and then the next hop to which, if I'm in the main router, let's say, and then as you can see here, sorry, as you can see here, I'm in the main router. If I want to hop from this router to this router, I will take the IP address of this network. The network of these two is 192.168.24.180. Yes, 180 here, and then 255.255.252, because the subnet mask is 30. that is the subnet mask, and then the next hub would be this 192.168.24.182, because that is where we are trying to go over here. Okay, that's basically how it is. Now if you want to go to different networks, let's say in the clinic, you just type it out 192.168.24.168, but and that is the network. Usually when you make uh, a networking structure, always label them. That's why this is very useful. You just type in the network addresses, the IP addresses of each and every network of your department, of your departments. Always type the default gateways, because it's always helpful, and so that you know when you configure your network infrastructure. Now, and each of these routers, the router helpers, has their own statics, and it's quite few compared to the main router, because the main router is the one that's giving all of these routers their IP addresses. Okay, so I think the most advanced in this uh, network infrastructure is probably this. It's the VLAN database. Now, when you're trying to make a VLAN, it's quite simple. You put in the number, let's say 11114, and then you name it public one. You add it, and then you go to the port that is connected to the router. In this case, we are connected to gigabit internet Ethernet 01. That is the one connected to the router, and then you change this and you trunk it. And then when you trunk it, it automatically selects all of this, because it allows all of the things that the router can provide. And then in the router here, it doesn't have, if you notice, this doesn't have any IPv4 address or a subnet mask. Why? Because instead, it has it has a bunch of VLANs. It has it has an encapsulation .1q 11111. Then when you create a VLAN, right, it's interface gigabit internet, or whatever the serial name, the port name is, and then you put a dot and then the number of the VLAN, then you enter, and then you type in encapsulation .1q 111, because .1q is the standard for making VLANs, and then after that, that is when you put your IP address for that specific VLAN, IP address helper, so that you could utilize the DHCP relay service of the server that we have checked before, and then you just go along with that. The second, public or the student Wi-Fi access, the third, the fourth, and the fifth. And then you don't need to create an IP here, because it's only looking at uh, this this one, the encapsulated VLAN from the router to the switch. That's how you can make your switch have different networks. And then if you go to the switch, as you can see, it has 1111, has 112, we have 113, at 114, we have 115, and each of them has their own I mean network, that they can access through the switch to the router, to the server, to the DHCP IPv4 access. And I think that is all. You could create something like this. I'm going to send this file to the description, so that some of you can check it out and use it as a reference for your projects or whatever. This is a very simple one. This is not networking, and Cisco has a lot of things that it can show you and can teach you. This is just the tip of the iceberg. And if you're in like me interested in networking, this would be a very very fun self project that you can use. Oh yeah, by the way, you can also make a CCTV system that is actually working via using the IoT service here in the server. And I think that's all that I can give to you guys, and I think I'm gonna end it here. Thank you for watching.